as what you're using to read like a heartbeat. That was a mistake. You can't really use that. I have to use a transimpedance amplifier to measure current coming out of it. What I didn't expect to be tricky, was the filter design. And this is where a lot of the magic happens. So it all started with this guy named Zimmerman. He worked for the MIT Media Labs, and they were measuring Yo-Yo Ma's cello performance using similar devices. I'll talk about more of that later. I'm going to run out of time really quickly because I timed myself at 16 minutes. So if you want to know more about that history, ask me later. But the more interesting thing I found out during my research was that the human body is really quite a good conductor underneath the skin. Like we all did our measurements where we figured out our resistance, and it's in the mega ohms, but that's on the skin level. Once you get to the gooey insides, we're a really good conductor. Like bone is on the order of like hundreds of ohm meters, but because blood is like 1.5 ohm meters. Because blood is so pervasive throughout the human body, we're really good conductors. And because of that, we can treat the human body as a node. We can give a human body a voltage on one end, and these electric field lines can be transmitted to the other side. And this is what allows us to transfer electrical signals. There are really four main parts of this. There's the transmitter, receiver, and of course ground. And once you have an idea set up like this, we can create a very idealized circuit element. And it's going to look something like this. It's kind of confusing at first, but once you figure out where to draw your lines, it's really quite simple. So the capacitance between our transmitting pad and the human body is about 10 picofarads. And I measured this using just ordinary lab equipment, and it's about right. But this changes drastically depending on, of course, like where the pad is on the body, if it's loosely coupled or if it's tightly coupled, the size of the pad, and et cetera, et cetera. So also, if you notice, it really depends on the human body being separated from ground. And because of that, if the human body ever grounds itself, if you're wearing flip-flops on top of wet ground, or if you're touching anything metal, you will attenuate signal very, very, very quickly. So one of the more interesting things out of the Zimmerman study was the frequency response of the human body, where it drops off really quickly below 200 kilohertz, but it peaks at about 330 kilohertz. And that's where the Zimmerman prototype starts. The transmitter I use is very simple. It's just a 555 timer, set to pulsate at 300 kilohertz, 50% duty cycle. All these parts I got from Radio Shack. The transmitting pad that you see there on the side is made out of tin foil, business cards, and packing tape. And it's very important that you don't actually conduct through your transmitting pad. You just want to induce current. And the induced current will cause picocurrent to travel across the human body and to register as a voltage on the other side. This is the decoder circuit I was working on. This worked, although because of troubles with the filtering stage, I wasn't able to implement it. It's a frequency divider using D flip-flops. So what I have set up here is a transimpedance amplifier and a comparator. So what you get on the other side can be very considerable. I'm pushing out 9 volts peak to peak into the body and receiving 600 millivolts peak to peak on the other side. That's a drop about negative 10 decibels or so. It can look clean, but this is the best case scenario. It attenuates really, really quickly, and it's very prone to noise. Also, it's sitting at the upper range of my voltage input, on the upper range of my rail. It took me like a week to figure this out. And I was pulling my hair out the entire time trying to figure out why my amplifier filters design wasn't working. I finally figured that out at the end. I think after that I could make it work. But why can't you use a comparator? Because it's not a consistent output. And that's the main reason why you can't use a comparator. It ranges, it goes high and it goes low. And then once you get noise, there's spikes, there's signal spikes inside your output. And because those spikes, you'll mess up your comparator outputs. So Zimmerman used a system kind of like this tank circuit on the bottom. He used to have some resonance on his output to save power. I'm not using that because I couldn't find inductors of the proper size of Radio Shack. But he uses an integrator to integrate over his signal at the rising and falling clock edges. And by doing that, he's able to compare his high time signal and his low time signal over the entire period. I think it would be interesting to try out a IRD modulator approach, similar to the way the remote control works, because they have similar problems. And it's kind of a straightforward design. And I'm kind of curious how it would work out with the with this type of signal. So demo time. So if you guys can see this, I have it rising and triggering every time I touch it. There's a lot of, I can't get a clean signal out because there's like a lot of, I think I'm getting coupling with, I'm getting interference from the AC. But it's triggering when I touch the pads. So just by touching these pads, I'm getting it to trigger. And you can see I'm getting a signal output. It will also work across 2 human bodies. So there's a volunteer. We can touch hands, do high fives, and send signals.
We'll go up there.
Sweet. Ready?
You guys have to jump too.
There you go. Any questions? Awesome.
Questions?
Oh, yes.
The more human bodies you add as that wave gets the output.
We can hold hands real quick. Yeah, it will drop eventually. Yeah.
Did you, by any chance, try like pricking a pin Indian? You said the conductivity of blood is so much higher. I didn't know if maybe.
Well, I never actually measured it myself. It came out of the earlier study trying to map the inside of the human body using resistance. There's actually products on the market that use that same study to like figure out how much body fat you have on. Any other questions?
Cool.